Hey Fixers! What is the most Pythonic way to convert a list to a tuple? Okay, so this question may seem trivial to you, but I promise you will learn something out of this video, so keep watching. So, given this list of elements, like you have a list of, say, 3 integers, you want to convert it to a tuple. So, let's dive right into the different methods of doing this. And I will motivate each method as I go over it. Okay, so the first method, the kind of naive approach, it is also the best and most Pythonic way of doing it if you just want to convert a single list to a tuple, is to use the tuple constructor. Okay, so the tuple constructor is a built-in function. You can pass any iterable. An iterable is a list, a set, another tuple, anything. You can pass any iterable here into this tuple constructor, and then it will just return a new tuple data structure that contains the same elements as the previous list. So it's like a flat copy, if you want, because it's not a deep copy, because if each element in the original list is already a list, then just this list will be placed into the tuple. So then we will just have a reference to the original list. But in this case, we will have a flat copy. So we will copy all integer elements into the list, into our new tuple, and this returns a copy of the, so basically of the elements. Yeah. So basically not a copy. It's a, yeah, if you want, it's like a new tuple data structure. Okay, so but why should you look for more? Let's see. Let's have a look at another method that you can use that is even more concise than the previous method. So how could this be? I mean, here we just use like 10 characters to convert this list to a tuple. So how can we be even more concise? So the answer is we use the asterisk operator and unpack the elements into an outer tuple data structure. Okay, so first of all, we need to create a new tuple. Okay, and then the naive approach is to simply create a new tuple with the parenthesis operation. But now Python actually believes that this is just an expression, and the parenthesis is the precedence operator. So basically, it's, if you want to do something like this, 2 plus 2 times 2, for example, yeah. Now it would calculate first 2 plus 2 and then 2 plus 2, and then it would multiply it with the value 2. So it would not like multiply it in advance. So therefore, you need to differentiate for Python. Otherwise, Python will believe that this is just a normal precedence operator. You need to differentiate that you actually create or want to create a new tuple data structure. You need to use this comma notation. Okay, so because now it's clear you want to create a new tuple. So even a tuple with one element is written like this, okay? So a tuple with one element is not written like this, because then again it thinks that it's an expression. It is written like this, so that it's clear, okay, now this is a tuple data structure. So you have like a tuple with a comma notation, but there's only one element in the tuple. Okay, and now we need to replace this element, and we can use the asterisk operator to unpack all elements in our original list, like this, okay? So we have the asterisk operator that can be applied to any iterable, like a list, for example, and you can simply unpack all these elements into this outer tuple data structure. But you can use unpacking only if there is an outer collection, an outer structure, if you want, that can actually collect all these values that you unpack. Yeah, so this can be either an argument list. For example, you often see it in function calls where the function expects a list of values, and then you can use the unpacking operator to unpack all these values into your argument list. Or it can be another collection type from tuple, list, set, or so. That is capable of catching all the elements that you unpack, because you can think of it this way: the asterisk operator simply removes the outer bracket, so it removes the outer data structure and places all the elements into a new outer data structure. Okay, and this is what we are doing here. So we remove the outer list, the square brackets, if you want, and replace the square brackets with our tuple parenthesis. So this is basically what happens here. It's a very short, very concise way of creating a tuple, and it also has some use. Okay, so in this case, I would probably advise against using it, because even if it's more concise and equally efficient, you could use it and nobody would blame you, but it's not as readable, and you know that you should write readable code, because other people or you will read your code at a point in the future, and they have to think to understand this thing here, and they don't have to think to understand the tuple, the default tuple constructor method. Okay, but actually what is the use of this method? You will see it in method 3 if we have multiple lists. Say so we have one list with 3 elements, and then we have another list called list 2 with other elements, and now we want to create a new tuple consisting of all the elements in both list 1 and list 2. So now this can be easily done with unpacking list 1 and unpacking list 2 into the outer tuple data structure. Now it's very readable actually. Yeah, so it's I would say it's even more readable than concatenating this thing and writing and using the tuple constructor. So this now has some use. Even if you have more and more lists, then the unpacking asterisk operator becomes more and more advantageous in terms of efficiency. Because, I mean, the alternative would be to actually use the tuple constructor and then concatenate the first list to the second list. But actually what you are doing now is you create a new helper data structure, list 1 and list 2, so that you create a new list that is just a temporary data structure in memory, and then you place all elements into a new tuple. So that your memory still contains this new helper data structure, even if you don't use it later, this list of all elements. And this has to be removed by the garbage collector in Python. So this is not very efficient. So because, I mean, creating a data structure that is not used and removing it immediately afterward, it's not the most efficient way of doing it. So therefore this way is both more concise and faster. So, and therefore unpacking multiple lists into the outer tuple data structure is a very efficient way of doing it. And you can see that it actually does what it promises. So it creates a new tuple of all the elements. So this is quite useful to know actually. And now you may ask, what happens if you have a list of lists? So if you have many lists, you not only 2 or 3 or a constant number of lists, but an arbitrary number of lists stored in a list of lists. So say you have the following list of lists here with 3 lists, 1, 2, 3, 4, and 5, 6, 7, and you want to unpack all of them, or now I already give you the solution. You want to convert all of them into a single tuple. How can you do it? Yeah, basically you can, again, we use a tuple constructor, and as I said, the tuple constructor expects an iterable of values, and the iterable can be created using a generator expression in Python. So what is a generator expression? Generator expression consists of an expression and a context part. The context part returns us certain number of elements for which you want to apply some expression, and the expression is just an identity expression, so we just replace it with x. Now we need to define x in the context, so we go over all list elements, we call them L in list. Okay, so we go over all list element in the list. So the first value of L will be 1, 2, will be this first list. The second value will be 3, 4. The third value will be 5, 6, 7. And now we go over all elements in the list. Okay, so many people don't know that you can use this nested for loop statements in a generator expression or a list comprehension statement. And yeah, but now we do this. We go over all elements. We call the element X. We simply place the element X in a generator expression, and this creates a new iterable. And now we can pass this iterable into the tuple constructor, as you have seen here in the first method. So this is like the general approach of doing it. You cannot use unpacking here because you have an arbitrary number of elements, and there's no way of unpacking an arbitrary elements into a tuple. So for example, if you would like to do something on those lines, I will quickly show you what you could try to do is unpack the list for a list in unpack the list L for L in our outer list. Okay, so this, you could try this one. It seems to be shorter, but it will throw an error because you cannot use unpacking in a generator expression. It will just throw an error. You can see it invalid syntax. Okay, so you cannot use unpacking in this context. So therefore you have to do this nested loop thing. So you go over all lists in your outer list, and now you go over each element in the inner list, and you simply place this element in a new iterable, and then you convert the iterable to a tuple. Okay, so this method 4 is quite effective to convert an arbitrary number of lists into a single tuple. Okay, so let's print the result. We haven't printed it yet. Okay, here you see, okay, we have placed all the elements in the outer list. And there's an alternative. This is now just for fun. Method 5. You already know with this strange syntax, this opening parenthesis, then the comma, and then immediately the closing parenthesis. This indicates that you want to create a tuple. Okay, and you can use it, of course, to like we use this structure to tell Python, okay, now we want to create a new tuple again. And here in the first element, the only element in the tuple, you basically now unpack the result of a generator expression. So let's call it gen. Okay, and now you need to define what is this generator expression. So you unpack all values from a generator expression, and now you of course can use another parenthesis. Now this one is not a tuple, it's just a parenthesis for a simple indicating that you have an expression coming. And now you go again x for L in list for x in L. So this is exactly the same as discussed previously here. And here you see it's the same. But now you unpack all these values into an outer tuple data structure, and this of course also creates a tuple. So if you print this, we have exactly the same output as previously. So you see it here, okay? Both of them have the same output. Okay, so these are the 5 methods I want to discuss. The most Pythonic way probably always is the tuple constructor. Just use tuple constructor. It's readable, it's efficient, so just use it for default conversion. If you have multiple lists or just for fun, you can also use the asterisk operator. If you have a list of lists, so an arbitrary number of lists, not a fixed amount of multiple lists, but that you want to convert to a single tuple, but you have many lists, then of course you should use this generator expression. I think this is the most Pythonic way of doing it. Okay, thanks for listening to this video. If you like the video, then check out my email academy with blog.finster.com/subscribe. I will give a lot of free content there. I will teach you all kinds of Python topics about NumPy, different data structures, data science, freelancing in Python, and so on and so on. So you can just find a link below in my academy. So check it out, it's free, and see you soon. Bye.